Hi, I am Frances Campoy and this is Just for Funk. So today I'm going to be trying something new for me. I'm going to be reviewing some code and sending a pull request while recording myself on the video. I hope you will enjoy this. It's kind of an experiment. I've never seen anyone else doing this. I've seen kind of like Andrew Duran and Brad Fitzpatrick doing the hacking with Andrew and Brad. I'm trying to do something similar to that. So let's see how it goes. So a couple days ago, I saw this tweet from my friend Philip Thomas mentioning that he had written a scraper, a concurrent scraper in Go. And I was like, oh, let me check it out. So I went and checked out the code, and it turns out the code is pretty simple. It has a bunch of different files, main.go, scraper.go, site.go, tasking.go, writer.go. So I thought, I was like, ooh, this is going to be quite complicated. But it turns out that it is total around, I think it's like 200 lines of code. What the program does is, so you call the binary, either scraper or whatever it's called, you give it a URL, and then that URL has a pattern here, %d, that will be substituted by some ID. So in this case, it will do http foo.com/123 up to 9. And then you can choose how many Go routines you want to use at the same time. So there's the concurrency flag, then there's the output flag to choose where you should be writing the output to. Then the name query, address query, phone query, and email query are actually the CSS selectors that we're going to be using to find whatever we're looking for, like the name or the address, in the URL, in the web page under the URL foo.com/1, for instance. So let me first get the code. So to get the code into my own machine, what I'm going to do is use go get. So I'm going to do go get of the repo URL. That will download the code into my local machine. And now I can just visit that directory, and I will have all the code in here. Great. So I have the code in my directory here, and I create a new branch. It's called work, just so I can have all my commits, all my changes directly here. So I'm going to navigate the code and understand what it's doing first, and then we'll start modifying it. So my favorite editor nowadays is VS Code. So I'm going to open that one, and now have VS Code open here. And we can see we have main.go, and main.go defines all the flags that we saw before, parses those flags, and then we'll see this in a minute, but uses a wait group and channels to communicate with different parts of the work. But the different parts are emit tasks, scrape, and write sites. So basically what we're doing is emit tasks will generate every single task that we need to do. So every task is actually a URL with an ID. So it will be something like example.com/v/1, another task will be 2, and so on. And that will be sending them into the task channel. Then scrape is a worker that will receive from the task channel, and we'll receive those IDs, and we'll go get them, parse whatever we need to find, and then put the result into the data chan. And finally, data chan, what it does, it just writes all the output to the CSV file. That is pretty much it. It is pretty simple. We can go a little bit into the detail of how this is done. Emit tasks, what it's doing is just sending data into task chan. Task chan is so site is a struct that contains a bunch of things, but we're using only the URL and the ID, which are the only things that we need to be able to scrape something. Then we have scrape, and scrape simply calls the function fetch on every single one of the tasks that we have, and that's gonna be doing the HTTP get. And then check that everything went fine, parse the document with Go query with an HTML parser, and then find whatever we want, the name, the address, the phone, and the email, and set it into the receiver of this method, site. And finally, we have write sites. And write sites, actually, let me go to the definition instead. Write sites, what it's going to do is it's going to create a new file, and write all the headers and every single one of the values getting from the data chain, the output of scrape, into that file, and then just close the file at the end. Pretty simple, right? Let's see how we could improve it. So I'm gonna start by doing something that is kind of a personal taste. I saw this in a talk by Peter Bergen in GopherCon, which is rather than having flags that are global and you can use them from anywhere. Like for instance, let's see, where is URL based used? Final references. URL base is being used here in this file to parse it, but then also in tasking.go here. And in this function, I actually don't like this much because that URL base is implicitly a dependency for that function, but it's not that clear that it is actually ever used, right? So I don't like that. I'd rather pass those as parameters. So what I'm gonna do is I'm gonna start by deleting all of this. Now everything fails, absolutely, and that is normal. And now what we're gonna do is, rather than using the global flag URL base, we're gonna use flag.string to define a new variable. And we're gonna do this for every single one of the flags that we have. Great, now when we do this, URL base and IDLO, etc. will not be strings and integers, will be pointers to strings and pointers to integers, as you can see here, which means that every single time we want to use them, we're gonna need to dereference them. We know as flags that they will never be nil, so we can just directly dereference it. That is pretty easy. And concurrency will also be dereferenced. Great. Now, does this work? Well, let's try to build it. Go install. And no, it doesn't. And it kind of makes sense that it doesn't compile, because all of a sudden, all the files we're using these variables, these global variables, and they're not global anymore. So let's go to emit tasks. And emit task was using URL base. URL base, now we need to pass it somehow. So I'm gonna set that this is a parameter. And ID low and ID high are also parameters of type integer. And we need to pass the parameters URL base, ID low, and ID high. Let's see. Let's do the same thing with scrape. We have the task channel, the data channel. So this is actually good. But let's see in here. So in here, we have a similar problem because name query and address query and phone query are not defined. So let's define them. Let's pass them as parameters too. So name query, address query, and phone query, which are all strings. Now all of this compiles, but this one will not be compiling. Actually, this definition will not be compiling because we need the same parameters. So let me pass those here too. We need to pass them as parameters to the scrape function. And finally, we need to pass them here. And query, address query, phone query. And finally, write size. And write size has a similar problem with out file. So we're gonna pass out file as a string, as a parameter, and everything else should work. And we're gonna pass it here, out file. Great. Oh, this doesn't compile. Let's see what other errors we have. So just that one, email query declared and not used. Well, that is weird, right? Why is it that happening? Well, we're not using it anywhere, and we have not changed much, really. Everything we've changed is that those global variables that were accessed implicitly, now they're accessed explicitly through parameters. And we're not passing that as any parameter. And it feels like it should be passing here, name query, address query, phone query, probably email query. But if we go to the definition of this function that calls this other function, we will see that we use name query, address query, phone query, and phone query again for email. So this is actually a bug. So let's fix that one and add a new parameter. Email query, email query, email query, and finally email query. Cool. Let's see if this compiles. Nice. Okay, so we know that this now compiles completely, which is cool. It used to compile before, so we had not improved it that much, really. Well, other than we actually fixed the bug. Let's see, what can we do next? So next, I want to understand what emit tasks is actually doing. And if we go to definition, it is so simple. It's just simply a for loop. So rather than having an extra file and an extra function for this, I'm gonna move it directly into the main.go. So I'm just gonna delete this file. Tasking.go is gonna be deleted. Goodbye. And instead, I'm going to have this function here. Now, of course, this needs to be executed in a different function and in a different Go routine. But we can easily do that by doing this. And now ID low and ID high and URL base are all pointers, so we need to dereference them. Great, now we're doing exactly the same thing as before. But I feel like this is slightly easier to follow. So, okay, so the first thing we do, if we ignore all of these channels, is we go from ID low to ID high, and we create a URL base. So we're substituting the person D in the URL with the ID that we had. And then we're sending that to task.gen. Then we start n as many workers as concurrency says. And this function, what it's doing is actually, again, kind of doing just the same simple loop. So again, I'm going to delete scraper.go and move it to here. So we're going to do again, go func. And I'm going to get rid of all of this. Okay, we need to pass name query, address query, phone query, and email query. Cool. Okay, so for now what we've done is basically compact a little bit the code, which makes it easier to follow. So we have this first Go routine that will send all the data into a channel, then a bunch of other Go routines that will read from that channel. Task.gen is here, and we'll be calling fetch on those. And finally, write sides. And write sides, what it's going to do is it's going to write some file into the output. Cool. There's a little bit of a problem here. This code works and it is technically correct, but there's a little bit of a problem because we are leaking Go routines. Let me explain how we're doing that. Okay, so this Go routine here will send a bunch of tasks into the task channel, and then we'll finish. So we're not leaking this one. This Go routine will actually finish. Great. But what about these ones? Well, these ones are in an infinite for loop. What we're gonna do is we're going to have all those Go routines running forever. When we stop sending data into the task channel, they will block forever, but they will still be there. So now we effectively have Go routines that are there forever. Fortunately, in this case, write size also uses a wait group, and that wait group will let us wait for as many tasks as we have. So write sides, what it's going to do is going to call done on that wait group for every single task that it processes. And then finally, once we're done, this wait will pass, will not be blocking anymore, and we will exit the main Go routine and everything will be shut down. But if you use this as a library, all the Go routines created here could be blocked forever, and the Go routine using write sides could be blocked forever. So I'm gonna propose doing something different. Let's get rid, instead of counting how many tasks we have, what I'm gonna do is I'm gonna count how many workers we have, which is a slightly different thing. So I'm gonna say concurrency, and I'm gonna use it. I'm gonna move it for a little bit lower. I'm gonna move it to right before we start all the workers. Now for naming, I'm gonna change a couple names because I don't really like these names. So task gen. Right now, I don't really like the name because it is obviously a channel. You don't need to name it Chan. So I'm just gonna call it tasks. And then data Chan, I'm gonna change the name to results. Great. So now what we're doing is we're sending all that data into tasks, and then these go routines, rather than receiving from tasks all the time, what we're gonna do is we're gonna arrange over tasks. This is pretty much the same. The only difference is that once the channel will be closed, the for loop will finish and the go routine will finish. So what we need to add is we need to add, once we're done adding all the tasks, we close the channel. Now we know that all the go routines, all the tasks will be in that channel, and at the end, the channel will close. Which means that the workers will be able to get all of those tasks. And once the channel is done, they will be also done. So they will call done. And they're basically letting us know that all the go routines, all the workers are done. Why do we need this? Well, we're gonna do something really similar to results. I want results to be closed at some point. But at what point? So it is actually pretty simple. Basically, the last worker to finish using results should close it. And how do we know that? Well, instead of trying to let the worker know that it is the last worker to use the channel, we're gonna create one extra go routine. And that go routine is gonna do is it's gonna wait on the wait group to be done. And once it's done, it will close results. Okay, so let's try to understand what this is doing. So we create a wait group saying there's n workers. And you should, if you wait, you're gonna need to wait for n workers to be done. And then we create the channel. Finally, we say whenever all workers are done, close the channel. And then we start every single one of the workers. Great. What's next? Well, now this wait doesn't need to be there. This doesn't need to be here. This doesn't need to be here, because now what we're gonna do is right sides will not be using that wait group. So let's drop all the usages of it. And instead of having an infinite loop, it's gonna do something pretty similar to what we were doing before. We're gonna use a range. And now when we're doing that range, the cool thing is that whenever data chan is closed, which is the results, actually, let's change the name. I like the name results better. Oh, let me try again. Okay, so now when results is closed, this will be done. And then we'll go back to main.go and we'll finish the main.go. So this is kind of similar, but now what we're doing is we have one channel that has all the tasks. We start all the workers, and then when all the workers are done, we close the results channel. Then the consumer of that results channel, which is the right sides function, will finish at the end when those results have all been processed and the channel gets closed. Simple, right? So how can we improve it even better? So something that I'm not very happy with is the fact that both tasks and results have actually the same type. They're both channels of sites. And tasks, the only information we need is just the URL and the ID. So why are we passing URL, the body, the ID, the address, the phone, the email, so many things? Let me change that. And instead of passing all of that data, we're gonna create a new type that I'm gonna call task, which is a struct and has the URL, which is a string, and the ID, which is an integer. So now we just pass a task. There you go. We're passing a task to the channel of tasks. And this one will not complain because this is now a task. And we need to create a new site. Well, let's see that, because I'm actually not very happy with that either. Okay, so what I'm gonna do is in fetch, rather than having a method fetch on the type site, what I'm gonna do is I'm gonna have fetch return a site. And rather than handling the error in this weird way, we'll return a site and an error. Great, so now the URL and the ID are needed. So the URL is a string and the ID, which is an int, will also be parameters. Now, if something fails, rather than just keeping track of it, we're gonna return nil as the pointer to site, and then the error that will contain some information. Could not get this URL and this Y. So this is the URL and this Y. This complains. Okay, cool. Gonna remove that comment. I don't think it's needed. When you do a GET request in Go, when you do an HTTP request, if you use the body, you're responsible to close it. And we're gonna be using the body a little bit later, so that's why we need to close it at the end. I'm gonna change this too, because instead of 200, I prefer to use status OK. It is the same thing. If you look at the definition of status OK, is a constant, which is the value 200 in the HTTP package. But I feel like this makes it a little bit easier to read. And for 429, I actually don't know what is the name. So what I'm gonna do is I'm gonna go to the definition of the status OK, find 429. There you go, status too many requests. So I'm gonna call that status too many requests. And I could say that this is probably more readable, to the point that you don't need that comment anymore. I think log fatal is a little bit too radical in this case, a little bit too rough. So I'd rather return an error saying rate limiting detected or something like that. Otherwise, we're gonna return an error. So nil in the error. And so in Go, it is actually not idiomatic to use uppercase in the error messages, because you're gonna be chaining them, so it doesn't really help with the readability. But response from server, instead of saying status code like this, what I'm gonna do is I'm gonna use the status, which is a string rather than the status code. The status code could be 200, for instance, and it could say just 200. Status, the string will be 200, okay. So you will contain both the code and also the English translation of that code. Great, so now we're loading that response into Go query, and we're not handling that error. That is bad. Let's handle that error too. So if the error is not nil, we should return no site, and error F could not parse that URL, and this is the error, that is the URL, and that is the error. And finally, if everything goes well, we're gonna return a site, pointer to site, where the name's gonna be this, the address gonna be this, the phone's gonna be this, oops, and the email is gonna be the same, and then we can everywhere. Cool, and no error. Also, we're gonna set, so the error here is not used anymore. Body, we never used it, so no idea why it's there. So let's drop it. So we have the address, the phone, the email, the name, the URL, and the ID. So let's add also those. URL is URL, ID is ID. Great. Okay, so now I like this function much better. It's very clear what it's doing, and the error is just returned directly. So if we go here, fetch, now returns a site and an error when you give it the URL and the ID. If the error is not nil, we should do something about it. Let's just log it. Could not fetch. So that is the error. And then continue. And if that actually worked, we're gonna send site, wait, undefined URL. Oh, that is t.url and t.id, because those are the values we're getting from the task. Finally, oh, so now since fetch returns a pointer to site, site is a pointer to site, not a site directly. So I'm gonna change the value of the channel to be a pointer to site. And now everything works, except for the fact that write sites also expects a channel to site, so channel to pointer to site. Error, the sites don't have errors anymore, so we can just drop this whole thing. And I think we can drop this comment here. Okay, so this is much simpler now. So what we do at the end is we create a file. It's also return an error rather than panicking. Error F. We are writing some output. So the data row headers. And then we're also writing the data row. Let's see, we'll see in a minute that, but it is, and then it's flushing and checking for that error. And that is something we need to do only once, really. So I'm going to move flush. We want to make sure we do that. So we do it at the end. And rather than panicking again, we're gonna just return an error. And could not write. And if everything goes well, we're just writing the error. Great. Okay, so now we have this function is, I could say, much simpler, but we can probably do better. So how can we improve this now? Okay, so I think that at this point, it is interesting to see why we have a site type at all. Do we actually need it? And if we see how we're using it, writer.go, what it's doing is just simply calling data row. And data row returns a list of strings, a slice of strings that contains the ID, the name, the URL, the address, the phone, and the email. So it's basically a list of strings, right? What I'm gonna do is, rather than returning a site, I'm gonna try to just drop site completely and use instead a slice of string, because really that is what we're doing. So rather than returning this, I'm gonna return a slice of string. I'm gonna have URL. So URL, ID, name, phone, anyway. URL is already a string, but ID is not. And rather than doing fun.sprintf, I'm gonna do a string conv of I to A, so integer to ASCII, and that will return a string given an integer. Okay, so now what we're returning is all the values, and interestingly enough, those values do not match the values in here. ID, name, URL, address. URL is actually the first one. So let's do it like this. So URL, ID, name, address, phone, and email. So those are the ones that we're using. So those are the headers. And I'm gonna define them in my main function because I think they should be next to the flags because they're actually very tied to that. So headers, I'm gonna define those are the ones. Now, this will be, results will be a channel of slice of strings instead. And when we call writer.go, this will be slice of strings. The header should be passed. So headers is going to be string. And we're just going to print that because S now is a slice of strings. So now we're pretty much doing the same, but rather than having a site type that is passed around, we're just passing a slice of strings, which is much simpler. Great. What else could we do? Oh, this doesn't compile because results is a channel of slice of strings. Oh, we need to pass headers. And also this returns an error. If there is no nil, we should print it. Could not dump CSV. Okay, so next, what I'm gonna do is, I'm not a big fan of this name query, address query, phone query, email query thing. So I'm gonna just rename them to be name, address, phone, and email. And not only that, but I'm going to define columns, which is gonna be a string, and I'm gonna have name, sorry. So name, address, phone, and email, following the same order as we had in here. I'm actually gonna switch them. And even better, I'm gonna say that we start with URL ID and then the rest of the headers. Columns is not being used anywhere, but what I want to do is, rather than passing name, address, phone, and email, I'm just gonna pass columns here. So fetch, now rather than having all of this, we'll have a list of queries which are just strings. And rather than doing this one by one, we're gonna start with something that only contains URL and ID, and then we're gonna do this for every query. And finally, return S. We can make this a little bit more compact by moving this around. Cool, so now our fetch function doesn't know everything that is retrieving. So if we wanted to add more fields, it could be as simple as just passing one more query here and basically make sure that the flag, the columns, and the headers all match. Which I think it's pretty easy to keep track of all the things that are going on here. Great. So what else could we do? Okay, so my last change that I could do is, right now we have 3 files, 68 lines, 39 lines, and 35 lines, and they don't really need to be different files. So what I'm gonna do is I'm gonna put all the functions in the same file in the order we're calling them. So we have fetch. So I'm gonna go to site.go that defines fetch and move it here. And then writer.go, I'm gonna get the function right sides, gonna move it here, and I'm gonna delete both files. Writer.go, move to trash, site.go, move to trash. And now all our code fits in just 127 lines of code, which is pretty good. I think it's pretty simple to follow. So let's go through everything that it's doing now. Okay, so it's defining all of these flags that we care about, and it's using name, address, phone, and email as the column names, and also the header names. In the headers, there's 2 extra that we prepend, which are URL and ID. We create a bunch of tasks that are sent to this channel. We can make this even a little bit more compact. And once we're done sending all the tasks, we close that channel. Then we start as many workers as we need, and we track when they're done. Whenever they're done, we will close that results channel, which is the channel that workers are using to send the resulting data, which happens to be just a slice of strings. So every single one of those workers will get a task and get the result sent to results. If anything happens, we just log the error and continue. There's nothing extra we need to do, really. And whenever tasks is closed, which is when all the workers are done, we will exit the loop. Whenever this loop is done, which is when task is closed, which is the first channel I was talking about, we will all call done, And whenever all the workers are done, then this function up here will be the one closing results. Finally, we have with write sites, and write sites will be writing all the results into the output file, plus the headers that we gave it. And that is pretty much it. I think it's pretty simple. It is simpler to follow and probably doesn't have any bugs, hopefully. Anyway, I'm gonna send this as a pull request and hopefully we'll get merged. Thank you.